Hello students, in this video we are going to learn some basic trigonometric formulas that we are using in many more problems frequently and some tricks to memorize those trigonometric formulas. So first we will see about the trigonometric identities that we are going to learn in this video. Sin square theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to secant square theta. 1 plus cot square theta is equal to cosecant square theta. Tan theta is equal to sin theta by cos theta. And your cot theta is equal to cos theta divided by sin theta. These are all the most important trigonometric identities we are going to learn in this video, and some more formulas are also we can learn in this video. So first we will learn about trigonometric ratios. So consider this triangle ABC. So in this triangle, the AB, BC and AC are named as opposite side, adjacent side and hypotenuse respectively. That is, the side which is opposite to this angle theta is called as an opposite side, and the side which is adjacent to this angle theta is called as an adjacent side, and another side is called as hypotenuse side. So from this triangle we can write three trigonometric ratios in terms of sin theta, cos theta and tan theta. So sin theta is the opposite side divided by hypotenuse, and the cos theta is adjacent side divided by hypotenuse, and your tan theta is opposite side divided by adjacent side. So like trigonometric ratios, we can write inverse trigonometric ratios too. That is, cosecant theta is the inverse of sin theta, your secant theta is inverse of cos theta, and your cot theta is your inverse of tan theta. Hence, you can write some more trigonometric ratios, that is, as the cosecant theta is inverse of sin theta, we can write cosecant theta as hypotenuse divided by opposite, and as the secant theta is the inverse of cos theta, we can write secant theta as hypotenuse divided by adjacent, and as the cot theta is the inverse of tan theta, we can write cot theta as adjacent divided by opposite. So as we can say cosecant theta is the inverse of sin theta, we can also say that sin theta is also an inverse of cosecant theta, and cos theta is also an inverse of secant theta, and tan theta is also an inverse of cot theta. So then we will learn about complementary angles. So for this triangle ABC, AB is the opposite side, BC is the adjacent side, and AC is your hypotenuse side. So we can write that from the trigonometric ratios, sin theta is x by y, that is opposite by x by z, that is opposite by hypotenuse. Your cos theta is y by z, that is adjacent by hypotenuse, and your tan theta is x by y, that is opposite by adjacent. Your cosecant theta is z by x, that is inverse of sin. Secant theta is inverse of cos, that is z by y, and cot theta is inverse of tan, which is y by x. So we can write some complementary angles here. Sin 90 degree minus theta is equal to y by z. Cosecant 90 degree minus theta is z by y. Cos 90 degree minus theta is x by z, and secant 90 degree minus theta is z by x. Tan 90 degree minus theta is y by x. Cot 90 degree minus theta is x by y. So we can see sin 90 degree minus theta and cos. So we can see that your sin 90 theta and the cos 90 degree minus theta are same. which is x by z, and your cos theta and sin 90 degree minus theta are same, which is y by z, and tan theta and your cot 90 degree minus theta are same, which is x by y. Cot theta and tan 90 degree minus theta are same, which is y by x. Cosecant theta and secant 90 degree minus theta are same, which is z by x. Secant theta and cosecant 90 degree minus theta are same, which is z by y. Hence, sine is a complementary angle of cos. Cos is a complementary angle of sine. Tan is a complementary angle of cot. Cot is a complementary angle of tan. Cosecant is a complementary angle of secant. And secant is a complementary angle of cosecant. So, from this we can have three complementary angle pairs. That is sine and cos pair, tan and cot pair, secant and cosecant pair. So before learning the trigonometric identities, we have to first learn the Pythagoras theorem for a triangle ABC. So the Pythagoras theorem says the hypotenuse square is equal to the opposite square plus adjacent square. Hence, we can write the opposite square, that is x square, plus adjacent square y square is equal to your hypotenuse square, that is z square. So then let's divide the Pythagoras theorem 3 times by hypotenuse square, adjacent square and opposite square respectively. First we will divide by hypotenuse square. We will get the opposite square divided by hypotenuse square plus adjacent square divided by hypotenuse square is equal to hypotenuse square divided by hypotenuse square. So we know that already your opposite divided by hypotenuse is your sine theta. So opposite square by hypotenuse square is sine square theta. Your adjacent by hypotenuse is your cos theta. So adjacent square by hypotenuse will be written as cos square theta, and hypotenuse square by hypotenuse square will be equal to 1. Hence, we have derived the formula, that is trigonometry identity, sin square theta plus cos square theta is equal to 1. Then we will divide by adjacent square. Opposite square by adjacent square plus adjacent square by adjacent square is equal to hypotenuse square by adjacent square. Then your adjacent square by adjacent square will be equal to 1, and we already know that your opposite by adjacent is your tan theta. So opposite square by adjacent square will be written as tan square theta, and your hypotenuse by adjacent is your secant theta. So hypotenuse square by adjacent square will be written as secant square theta. Then we will finally divide by opposite square, that is opposite square by opposite square plus adjacent square by opposite square is equal to hypotenuse square by opposite square. So your opposite square by opposite square is equal to 1, and your adjacent by opposite is your cot theta. So adjacent square by opposite square will be written as cot square theta. Your hypotenuse by opposite is your cosecant theta. So hypotenuse square by opposite square will be written as cosecant square theta. So hence from this we have derived 3 trigonometric identities: sin square theta plus cos square theta equal to 1, 1 plus tan square theta equal to secant square theta, and 1 plus cot square theta equal to cosecant square theta. So these are all the three trigonometric identities we have derived from this video. So we have already derived the formula sin square theta plus cos square theta equal to 1. So from this formula we can write as sin square theta is equal to 1 minus cos square theta. Then we can have your sin theta as the square root of 1 minus cos square theta. and your cos square theta will be equal to 1 minus sin square theta, and your cos theta can be written as square root of 1 minus sin square theta. So then the next trigonometry identity is 1 plus tan square theta is secant square theta. So we can have another trigonometric identities from this formula, that is tan square theta is your secant square theta minus 1 and your tan theta is square root of secant square theta minus 1. So we can also write the secant square theta minus tan square theta is equal to 1. Then your 1 plus cot square theta is equal to cosecant square theta. So from this we can write cot square theta is equal to cosecant square theta minus 1. So cot theta is equal to square root of cosecant square theta minus 1. And your cosecant square theta minus cot square theta is equal to 1. So once you know the three trigonometric identities, you can write another 4 plus 3 plus 3, 10 trigonometric identities. So what you have to do is, you have to learn the only 3 trigonometric identities to know another 10 trigonometric identities. So finally, to learn those 10 plus 3, that is 13 trigonometric identities, you have to memorize just these 3 trigonometric ratios. It is sin theta, cos theta and tan theta, and these 3 complementary angle pairs, that is sin cos pair, tan cot pair, secant cosecant pair. So you have to memorize only 3 trigonometric ratios and these 3 complementary angle pairs only to learn 13 plus 13 trigonometric identities. I hope you all like this video. If you have any doubts or questions, feel free to ask me at yadumkeli20@gmail.com. So if I have left any of the formulas here, just remind me. Thank you.